Welcome to electricalworld360.com. In this video, we are going to solve the MCQs of 3-phase induction motor, and this is the part 7 video of this series. So before we start, if you are new to the channel, then please subscribe our channel, and if you want, you may follow us on Facebook also. And this is our Telegram channel, and usually whatever video I make, I used to upload all the PDFs in this channel. So to join our channel, you can simply search here Electrical World 360 official, and otherwise if you want, you may join our channel through this link also. So this is the question number 1. A 7.46 kilowatt 230 volt 3-phase 50 Hz 6-pole squirrel cage induction motor operates at a full load slip of 4% when rated voltage and the rated frequency are applied. What is the full load torque? So as we know, if we neglect the windage loss and the frictional losses, the gross mechanical power developed in the rotor will be the 7.46 kilowatt. Here you can see the 7.46 kilowatt, and in this case, as we know, the synchronous speed, that means ns, is equal to the 120 f by p. So here the frequency is 50 Hz, that means 120 into 50, and the divided by the number of poles is 6. So the synchronous speed will be 1000 rpm. Okay, so now we can easily find out the rotating speed, that means n. So as we know, the n is equal to 1 minus slip is equal to into synchronous speed. So here the 1 minus, here you can see the slip is 4%, so it will be 0.04 into the synchronous speed is 1000. So after solving this, we will get the 960 rpm, and this is the rotating speed. So as we know, the torque is equal to 9.55 into the power output divided by the rotating speed. So here you can see the 9.55 into this is the mechanical power output. Okay, that means 7.46 kilowatt, and it is in kilowatt. So to make it in watt, we need to multiply it with 10 to the power 3. 10 to the 3 means 1000 is equal to 10 to the power 3. So now it is in watt. So, and this is the rotating speed. Here you can see the 960. So here you can see the 960. So the torque will be 74.2 Nm. So here you can see the option number D is the right answer. This is the question number 2. The power input to the rotor of a 440 volt 50 Hz 6-pole induction motor is 80 kilowatt. The rotor EMF is observed to make 100 complete cycle per minute. What is the slip? So in this case, the rotor frequency is 100 complete cycle per minute, that means in 60 seconds. In 60 seconds 100 complete cycle. So here you can see the 100, the frequency will be 100 divided by 60 seconds, that means we can say the 5 by 3 Hz will be the rotor frequency. So as we know, the rotor frequency is equal to, that means f dash is equal to slip into the supply frequency. So you can write it like this way, that slip is equal to the rotor frequency divided by the supply frequency. So this is the rotor frequency, and the supply frequency is given on the question. Here you can see this is the supply frequency. So it will be 3.3%. Here you can see the option number B will be the right answer. This is the question number 3. In the last question, that means in this question, what is the mechanical power developed? So as we know, the mechanical power developed is equal to the rotor input into 1 minus S. This is the important formula, we need to remember this. So the rotor input is 80 kilowatt. Here you can see the 80 kilowatt, and this is the 1 and minus the slip. Slip is 3.3. So you can write it like this way. So after calculating, we will get the 77.36 kilowatt. To make it in watt, we need to multiply by 1000. So it will be in watt, and as we know, 1 watt is equal to the 746 I'm sorry, I mean 1 horsepower is equal to 746 watt. Okay, so that's why we need to divide it by 746. So it will be 103.6 horsepower. This is the mechanical power developed. So here you can see the option number A will be the right answer. This is the question number 4. In question number 2, what is the rotor copper loss per phase? So as you know, the rotor copper loss, this is also the important formula. The rotor copper loss is equal to the slip into the rotor input. The slip was 3.3%, so that's why we have written here 0.033, and this is the rotor input. So after solving this, we will get, as you know, the 80 kilowatt, and this is the 10 to the power 3. We have to multiply it because to make it in watt. So the rotor copper loss will be 2640 watt. And as we know, to find out the rotor copper loss per phase, we need to divide it by 3. So the rotor copper loss per phase will be the 880 watt. So here you can see the option number D will be the right answer. This is the question number 5. In question number 2, that means on that question, what is the rotor resistance per phase if the rotor current is 65 ampere? So in this case, as we know, the rotor copper loss per phase is equal to the I dash square, that means the rotor, the kind of the rotor square into the resistance of the rotor. So this is also the important formula. So the rotor current is given on the question. Here you can see this is the rotor current, the 65 ampere. So 65 square into the R2. So then, and this is the rotor copper loss per phase. Here you can see the rotor copper loss per phase. So from this equation, we can easily find out the value of R2, that means the rotor resistance. That means it will be 0.208 ohm. So here you can see the right option will be option number B. That means the rotor resistance is 0.208 ohm. This is the question number 6. A 12-pole 3-phase alternator is coupled to an engine running at 500 r.p.m. The alternator supplies a 3-phase induction motor which has the full load speed of 1440 r.p.m. The number of the poles of the motor is what? So as we know, the frequency is equal to the NP divided by 120. So here the N is 500, it is given on the question, and the P is 12. Here you can see this is the number of poles and this is the rotating speed 500 rpm. So divided by 120. So the frequency will be 50 Hz. So as we know, in the synchronous speed at 50 Hz, the rotating speeds are either 3000 or 1500 or 1000, because the N is equal to 120 F by P, and here the frequency is constant, that means 50 Hz. So you can see this is the induction motor which has the full load speed of 1440 rpm. So here the 1440 rpm is nearer to the 1500 rpm. So that's why we can say the number of poles of the motor is 4, because if we put here 4, then and if the frequency of the motor is 50 Hz, then the speed will be 1500 rpm. This will be the synchronous speed. So that's why here the option number A will be the right answer. That means the number of poles of the motor is 4. This is the question number 7. A 100 HP, that means horsepower, motor with a synchronous speed of 750 rpm at 50 Hz has 96 stator slots with 4 connectors per slots and 120 rotor slots with connectors per slots. If the full load efficiency is 0.92 and the power factor is 0.9 lagging, the current per phase when the stator is star connected, the rotor is wound 3-phase to 3-phase 500 volt supply will be what? So in this case, as we know, the line current is equal to the power divided by the root over 3 into the line voltage into the cos theta n. So after putting the values, here you can see these all values are given in the question. Here you can see this is the synchronous speed and this is the voltage and everything is given in the question. So after calculating this, we will get the line current, that means 104 ampere. So as you know, the phase current is equal to the line current, so that means the phase current will be 104 ampere. So that's why here the 104 ampere will be the right answer. So here you can see the option number C will be the right answer. This is the question number 8. In last question, the number of stator turns per phase is what? So as we know, the total stator conductors is 96 into 4. It will be 384. That means here you can see the 96 stator slots with 4 conductors. So that's why the 96 into 4, it will be 384 conductors. So as you know, the stator turns per phase will be 384 divided by 2 into 3. So the answer will be 64. So here you can see the option number C will be the right answer. This is the question number 9. A 25 horsepower 6 poles 50 Hz slip ring induction motors runs at 960 rpm at full load with a rotor current of 35 ampere. The copper loss in the short circuiting gear is 250 watt and the mechanical losses amount is 1000 watt. The total mechanical output will be what? So in this case, we need to find out the synchronous speed first. That means 120 F by P. So here the frequency is 50 Hz and the number of poles is 6. Here you can see. So the synchronous speed will be 1000 rpm. So from here we can find out the fractional slip. So the fractional slip will be, here you can see this is the synchronous speed minus the rotating speed divided by the synchronous speed. So this is the synchronous speed and this is the rotating speed. Here you can see in the question, and divided by the synchronous speed. So the fractional slip will be 0.04. So the output power, that means it will be 25 horsepower. So as we know, the 1 horsepower is equal to the 746 watt is equal to 1 horsepower. So that's why we have multiplied 25 with the 746. So the answer will be 18650 watt. So here you can see the option number. This is the output. So here we need to find out the total mechanical output. Okay. So here you can see this is the mechanical loss amount, that means 1000 watt, and this is the short circuit copper loss in the short circuit gears. So we need to add these amounts with this, that means 18650 plus 1000 plus, here you can see 250. Okay. So after adding this, then we will get 19900 watt. So here you can see the option number B will be the right answer. This is the question number 10. In last question, what is the rotor copper loss? So as you know, the rotor copper loss is equal to the mechanical power into the slip divided by 1 minus slip. So this is an important formula. So we need to remember this. Okay, so this is the mechanical power. Here you can see the 19900 watt. So 19900, and this is the sleep. So for sleep we need to find out the synchronous speed first. As you know, 120 f by p, so here the frequency is 50 Hz and the number of poles is 6. So the frequency will be 1000 rpm. So we need to find out the sleep. So as you know, sleep is equal to synchronous speed minus the rotating speed divided by the synchronous speed. So this is the synchronous speed and this is the rotating speed. It is given on the question. Here you can see 960 rpm, and this is the synchronous speed. So from here we will get the 4% will be the sleep. So we can write as 0.04. So here you can see the 0.04. Okay, so 1 minus 0.04. So the rotor copper loss will be 829 watt. So here you can see the option number A will be the right answer. So if you have liked our video, then please press the like button, and if you want, you may subscribe our channel. And to get the PDF of this video, you need to join us on Telegram. And don't forget to share this video with your friends also. And these are our links for to join our Telegram channel. So thank you for watching our video.